Hearing me dirty looks. So today's lesson is, it's super important. It's something that goes all the way through the rest of the year. It's not complicated. There's just one detail that children seem to forget. So we're gonna try to put a lot of stars and highlighting and stuff around that one detail, but the rest of it should be fine. Okay, so what I'm gonna ask every group to do, I have placed a 12-sided die over on table 1. They're going to roll the 12-sided die and remember their number. And then they're gonna pass it to table 2 and pass it to table 3. And then all 9 tables should have some number off of the 12-sided die for us to put on our dot plot. I don't know. Go ahead. Okay, everybody plot a 10. Real quick, hold on, let me unfreeze this. Just in case, I'm gonna do my dot plot at half box height.
One.
Table 2 is 1. I feel like we're playing bingo or something. Well, I feel like you should win something. I don't know what. I've got nothing. 8. The plot thickens. Ooh. Frequency of 2. I had a lot of caffeine. Four, as in like a bad golf shot. Nice. Ooh. I can transport. I've had caffeine. 3. I know, I just wanted to take attendance real quick. I was multitasking. Everybody went. I know. I was just trying to take attendance real quick. It's just Aaron. Guys, just to let you know, just because I saw how horrible the traffic was, I won't be marking any tardies today. That's not normal though. It's just because I drove here and everything was red and yellow, like everything everywhere.
Yeah.
It's not you, it's traffic. So, okay, back to this. Okay, there's my dot plot. Okay, what shape do you think this is, guys? Left skew? Okay, so the next thing I would like you guys to do is put these numbers into L1 in the graphing calculator, please, and run one variable stats and fill in these values. If you guys have stuff in your L1 column, just scroll to the very tippy top up in the heading, hit clear and enter, and it'll clear out the whole column for you. Just before I write my stuff down in pen, does anybody have the same answer as me? Okay. You just never know if you type it in wrong. Did we get the same thing? Did we get 7.5 for the IQR? Okay, great. Okay. And I think it'll make sense why we need to do this lesson. So what we're going to talk about today is what happens when you have a data set. That's our data set, our number rows. What happens when you add a number to the same number to every number in your data set? So I am going to add 3 to every number in our data set. Why would it happen in your real life? Why would you need to add the same number to every single number in your data set? I was thinking about this on the way to work this morning, and I only thought of 2 things, and one of them is very teachery. Anyone have any ideas though? I'm not the idea person. So I'm not surprised if you can't think of anything because it was hard for me to think of something. The first thing I thought of was like, let's say that I'm not going to call out Mr. Knight, but let's call out Mr. Knight and say that Mr. Knight had a question on a test that was terrible. And so he took it out and gave everybody 2 points. So he would take everybody's score and add 2. But I'm so teacher focused that that's what came to mind. And then the other one was somebody in this room's dad used to do this project where they grow sunflowers. I was thinking if you had a data set of growth, you would want to add their starting height, maybe, like to see how tall they actually ended up. Like if they all started at 3 centimeters tall, and then they measured their growth over a series of days, you might want to add 3 to all of the measurements to see how tall they ended up. This is the 2 things I came up with because I'm a teacher and my brain doesn't go anywhere else. But okay, so what we're going to do today is investigate. So we're using this fun dice thing that I came up with to investigate what happens when you take data and you add a number to every single number. Do you guys notice what I did with the number line? I did it on purpose. Did anybody see what I did with the number line? I lined it up. Yeah, but just so you know that it was supposed to, you'll see there's a, anyway. Okay, anyway, so 1 plus 3 is 4. 3 plus 3 is 6. 4 plus 3 is 7. 8 plus 3 is 11. 10 plus 3 is 13. 11 plus 3 is 14. 12 plus 3 is 15. Okay, and did the shape change? No. Okay, can you guys now put these numbers into L1, run one variable stat, and fill in this part? Now, if you're fancy, anybody who loves the calculator, technologically advanced people who want to be fancy, what you can do is you can go to the top of L2 and put L1 plus 3. And then you can run one variable stats on L2 instead of L1. That's advanced, like 4th degree black belt of graphing calculator stats, stuff right there. Or you could just type the numbers in again. That is exactly what I wanted you to discover, Jack Shaw. That was Avery. Sorry. I'm a mom and a teacher. I have that hearing. It's crazy. So you guys can say anything terrible about me, you're here, but definitely pick up on. Or you just shouldn't anyway, because I'm really not sure. But, okay. So there's a few things I wanted you to get from this, so from your investigation. And I wanted you to think about it in terms of shape, outliers, and terms of where. Okay, so the shape was not affected by moving it up to moving it. The center was affected. That makes sense, right? It went up 3. The spread, and these two things are both measures of spread. Just to note, I love all of you so very much, but the range did not count for spread. If you put the range on your test, that was fine. So if you're wondering at what point you missed, it might have been the range. So if it's mean, you should do standard deviation, and if it's median, you should do IQR. The range is useless. Okay. Just in case you were wondering out there. Anyway, okay, so these two are measures of spread, but what happened to those? This is the big moment, the big discovery. These did not change. And I want you to notice it graphically, so as a visual learner, I want you to really see that those coordinates did not get more spread out. They just shifted up the x-axis 3 units. So when you're adding or subtracting a number, is a shift up or down the x-axis of all the dots. Just like when you add a number on y equals mx plus b, it shifts it up and down the y-axis, but it doesn't change the slope. See what I'm saying? Yeah. So we're going to write underneath. So first thing I want to tell you is I'm going to highlight, if you want to highlight something or put box around something or those are the two things that were not affected by the +3. And then I'm going to add right here that adding a constant is a shift on the x-axis. So these two are same as the original data. Okay, so are you picking up what I'm laying down? The shape did not change. The center did change. The spread did not change. But Mrs. Talbot, you didn't talk about outliers. Well, because of the way the 1.5 times IQR rule works,
whatever outliers there were before will still be the same outliers. It's just that their numbers will be shifted up 3. So the position of the outliers don't change either. Okay, anyone have any questions about adding or subtracting? And do you guys understand that if I subtracted a number, it would just shift down that? Okay. All right, so now we're gonna do multiplying or dividing, which requires a big, big number line. If you have a tiny notebook, I'm very sorry. I set this notebook up for this lesson in like the middle of July. I have this like table and this TV in my exercise room, and then I just put on like some dumb show, and then I just knock these out. It's great. You guys are working on this, but don't move on without me. Just drawing, I mean. While you guys are drawing, I'm gonna bring you guys some papers. Um, these are things that we're gonna cut out and glue stick into our notes this chapter that are just too long to write. No, this is the style. If you have somebody that finished just setting up their notebook, you could send someone over to grab one of the baskets with the scissors and glue sticks in it. You'll see, I already have it muted, because.
That was so nice. That was so nice.
Guys, I love you. Pause on the arts and crafts. This is not arts and crafts time yet. Okay. We need to finish this first. I was just, unable to cool my jets. Okay, so what I'm going to do for this number line is I'm going to go back to the original dice rolls and I'm going to multiply them by 2. Do you guys see, can you look back up at your paper and notice that the first is 1 on not my paper, your paper. And notice that the first roll, the lowest roll was 1. Okay, so 1 times 2 is 2. 3 times 2 is 6. 4 times 2 is 8. 8 times 2 is 16. 10 times 2 is 20. 11 times 2 is 22. 12 times 2 is 24. Everybody see what I did? Original data, just took all of those numbers and multiplied them by 2. Can anyone think of a reason why you would multiply or divide a constant to all values? This one's actually much easier to think of something. For me. Why would you multiply or divide all of your numbers by the same number? Yes, exactly. Unit conversion is what I was thinking, like going from cups to liters, or I don't actually, can you go from cups to, I don't know. Going from meters to centimeters, or like change of units was what I was thinking. So we have to see what happens to our data when we multiply and divide by something. And I want you to see, first and foremost, that the shape did not change. It is still F skewed. And then can you guys enter these numbers in the calculator and find the rest of the data, please? If nothing else, you're going to be really good at one variable stats before you leave. No, that's fine.
Yeah, I'm prepared to.
That's fine. The rest of them aren't too bad. Just that's fine. So, okay. What happened to the center? Multiplied by 2. Standard deviation this time got multiplied by 2 also, and notice from the visual, you can definitely tell it's twice as spread out as the other one. The minimum times 2, median times 2, maximum times 2, IQR times 2. The times 2 affected everything. Okay, so this is the moral of the story from today. Multiplication and division affects everything, all the statistics that you find from that data set. And adding and subtracting only affects measures of location, meaning median, Q1, Q3, max, min, those things. So it doesn't affect the spread. Okay, turn your paper over to the other side if you're at the bottom, which I am. Okay, now it's arts and crafts time. So you're gonna set this part up, and then you're going to paste my temperature conversion example in underneath. Okay, while you guys are arts and craftsing, I'm gonna give you an I love you but moment. If you've been in my class before, you know what I love you but moment is. Alex, what you don't know? Okay, the Talbots are very sensitive people. My whole family were very sensitive. So it is our family rule that when we're going to give someone a bit of criticism in our family, we have to say, I love you but first. It's just an unspoken, not really unspoken, we just speak it. It is our family rule. Okay, so I'm gonna give you guys a little bit of criticism. I love you, but these are things I did not really even anticipate, so to tell you. First, the topic I'm speaking about is the AP Classroom FRQs.
You guys remember the AP Classroom FRPs? You did them on whiteboards, you typed them in. First, I looked at all of this. There's a person that's going to be looking at that. So you can't just summarize it, you can't just put the answers. You can't just get full credit for putting the final answer or summarizing your sentences. So if you missed points on the FRQs, that's because I actually graded them off of the rubric that I was reading when I walked in the room. Secondly, please do not post photos of the whiteboard. That is not what was the intention there. This test is going to be digital. Your AP exam is digital. The point of doing the FRQs in AP Classroom is to practice actually typing things into AP Classroom. Also, if you want to say, if you want to say less than, there's a symbol for that. If you want to say less than or equal to, it is acceptable to put less than and then the equal to sign. And your AP grader will read that as less than or equal to. So you don't have to type less than or equal to out in words. You do not need to type is divided by. You can just put the like /God. You know what I'm talking about? /God. Okay. You don't have to type is divided by. You don't have to type the words less than or equal to. I appreciate all of that, but I'm just trying to, yes. Oh. No, I'll go. Everybody understand my comments about those? I feel like there were people that thought that I just graded them off the whiteboard and wasn't actually going to read them. I read them all. So. They are, but I fumbled, wow. I put them all together with the MCQs, the FRQs, all in one score. But you should be able to go on AP Classroom and see where the points, where it says I selected full response, and you could look and see everything. If you can't, please let me know. AP Classroom is a mystery a little bit sometimes. Okay. All right, let's finish this up. Transforming data. Shape. Shape is not affected. So whatever the shape was, the shape is going to stay the same. Location.
Okay, before we move on, I trust that you understand what I mean by this, but I would like you to give me some examples of statistics that are measures of location. I'm looking for 1, 2, 3, 4, 5, 6, 7, 8 of them. No, wait, 1, 2, 3, 4, yeah, 8. Give me 8, not all at once. If anyone knows one measure of location, raise your hand. Yes, min. Yes. Max. Yes. Q1. Yes. Q3. You're doing great. You're halfway there. Yes. Median. Missing 3. 2 of them we learned yesterday. Z-score. Yes. Percentile. You guys are so smart. You're missing the most obvious one that you learned in 6th grade. Me. Okay, last one. Yes. I need 3 measures of spread. Yes. Standard deviation. Yes. IQR, and what's the useless one? Range. There's lots of others, but those are our top 3, even though range is dumb. Sorry, range. I'm sorry if I hurt range's feelings, but. Okay, do you guys all understand what I mean by measures of location and measures of spread? We did a lot of good chapter 1 review today. Because now you all know how to use a calculator, I'm hoping. Like, only if I could go back in time. Use a calculator on my head. Okay, a lot of you guys just did it by hand, which is fine. Okay, last thing. So we have this example. City has an average temperature of 25 degrees Celsius with a standard deviation of 3 degrees Celsius. Use the formula Fahrenheit equals 9 Celsius plus 32. That's the actual formula. To explain, describe the temperature distribution for this city in Fahrenheit. Okay, this is actually a useful example, perhaps. Maybe you're traveling and you like look things up in Celsius and they're like the average temperature is, I don't even know what reasonable temperatures are. I need to be more culturally diverse. But like what's that? I need to travel or go somewhere. Anyway, but what's like a reasonable outdoor temperature in Celsius? Okay, you guys are smarter than me. Okay, but you could see how this would actually be a helpful example. Okay, so first thing I'm going to do is I'm going to mark here that this is called a linear transformation. Can anyone think back to their math 1 and tell me why this is a linear transformation? First of all, do you know what the word transformation means? Like changing it. Okay, yes. Why is it linear?
Perfect. It's y equals mx plus b. It's just got fancy stuff in there. So your slope is 9/5 and your y-intercept is 32. So if you can recognize the 9/5 and the 32 as slope and y-intercept. Now, it doesn't have to have the plus 32. It could just be Fahrenheit equals 9/5 b. That's still linear, just means your y-intercept was 0. If it had f equals c plus 32, that's still linear, just means your slope is 1. Does that make sense? If those two things don't have to be specific numbers for it to be linear, it's just that you would have to be able to rewrite it in y equals mx plus b. So the shape, we don't know the shape of the original in Celsius. So what we're going to say is the shape in Fahrenheit is the same as the shape was in Celsius. We don't know what it was in Celsius, but we do know that whatever it was, it'll still be the same thing in Fahrenheit. Okay, can you guys tell me there's one number in this problem that is a measure of location. Which number in this problem is a measure of location? Yes. Okay. Other numbers, yes. 25. Yeah. Okay. So the location in this case is an average. So we have average equals 25 degrees Celsius. Okay. And measures of center. Measures of center, are they affected by multiplying? Yes. Are they affected by adding? Yes, both things. So location is affected by both, which means that I'm going to take the 25 and plug it in for Celsius. So Fahrenheit equals 9/5 times 25 plus 32, which is, oh yeah, you guys were right. You're more culturally aware than me. Mr. Talbot made me promise that we would go on vacation a different place before we go back to Disneyland. Anyway, okay, spread. Can you guys tell me a number in this problem that is a measure of spread? Standard deviation of 3 degrees Celsius. Also, I had no idea that the degrees comes before. I was writing this wrong my whole life. Yeah, I got it now. Okay, back to spread. Spread is affected by only multiplying and dividing a constant. Okay, so this is the detail I was talking about. You have to resist the urge to add the 32. You only multiply the 9/5. It's not going to get plus 32 more spread out. That's just a shift. Think about how much more spread out that would be if you added the 32. That would be a lot of spread. The only thing you're going to do is multiply. So location is affected by both. Spread is affected only by the multiplication piece. 9/5 times 3 is 5.4 degrees. And a lot of times students forget about that until they accidentally add the 32 and then they look at their number and they're like, that doesn't make any sense. The number for spread would be so huge that it like wouldn't make sense. But anyway, okay. Are you guys ready for my joke? Yeah. Right. Let's see. Okay. We had two objectives today. Understand the effect of adding or subtracting a constant to shape, outlier, center, and spread. Understand the effect of multiplying or dividing a constant to shape, outlier, center, and spread. I think we did it. Okay. Here's the homework, 21 to 31 odd, 33 to 36, which I think are all multiple choice. 39 and 40, I think are review ones. And my joke set. And here's a chart that shows what you might see if you look at a mountain range through a telescope.
I didn't say they all were good. I just said I have a joke every day.